Hello and welcome back to math class. Let's do some questions, some math questions. These can be quite instructive. Okay, here's a question. Here's a problem. Given that f of x is 4 to the x, which we know to be an increasing exponential function because x is in the exponent, and g of x is a version of f of x. G of x is negative 2 times f of x, but it's not f of x, it's f of 2x minus 6. So the input station has been changed and all the y values got multiplied by 2 and reflected across the x-axis. But let's formalize all this. First of all, let's find out what this 4 to the x looks like when we graph it. If you sub in 0 for x, 0, that's 4 to the 0, that's 1. So 0, 1 is part of it. If you sub in 1 for x, we have 4 to the 1, that's 4. So 1, 4, so when x is 1, f of x is 4, so 1, 4 is going to be part of it. And if I subbed in 2 for x, 4 to the 2 is 16, so 2, 16. So when I go to 2, I would expect to go up to 16, and that would be a part of it too. And we know there's an asymptote over here on the left. And it looks like this. This point right here is the result of subbing in negative 1. 4 to the negative 1 is a quarter. That's why when you go to negative 1, you put a quarter. And we have the software telling us what the function looks like. So that's f of x. f of x equals 4 to the x looks like that. Now how about g of x? Let's list the transformations. Well, what we do is, this says f of x, so we want to have x alone in those brackets, not with a 2 multiplier on it. So we'll factor out the 2. This is the same thing. This is still g of x, but I factored out the 2, so that x is just a positive singleton in here. And now we'll list the transformations left to right. On the left, we have a negative sign, which reflects it in the x-axis. Then there's a 2 that multiplies the y value, so it's a vertical stretch by a factor of 2. Now 2 is on the x. We can see it on the x here, but this is 2x. So this is 2, and that factors on the x inside this input station are a horizontal compression. So it's a horizontal compression by 2. It's going to divide all the x values by 2. And then it shifts to the right 3. It looks like it shifts to the right 6, but it doesn't. It shifts to the right 3. Because you can tell because you factor out the 2. So it shifts to the right 3. And that's a list of the transformations. We have a new equation for this. At the input station, we'll put 2x minus 6, or 2 times x minus 3, and we'll put a minus 2 factor out in front of the 4. So it looks like this. A new minus 2 factor out in front of the 4. This is 2x minus 6 if you multiplied it out. I use this version of it. And this is our new equation for g of x. Notice, we don't go 2 times 4 is 8. Don't be tempted to write a number 8 because this is protected by an exponent. Moving on. Let's find the y-intercept. Well, for any function you ever work with in advanced functions or university, to find a y-intercept, substitute in 0 for x. So there's our g of x. We'll substitute in 0 for x. And that'll give us the y-intercept. So if I put a 0 there, this is 2 times minus 3, which is minus 6. So this is how we're getting our y-intercept. Now the minus puts it on the bottom. And now you might have some fun with it. 4 is 2 squared, so this is 2 to the 12 on the bottom. 2 to the squared to the 6 is 2 to the 12. And so take this and divide top and bottom by 2, and we have negative 1 over 2 to the 11. And so that would be our y-intercept, which is pretty close to 0, because 1 over 2 to the 11 is like 0.05 or something. Let's find out. I remember I did this. Y-intercept, yes, it's 0.05, and it's negative. So it's just below that origin right there. It's practically the origin. That's the y-intercept of this g of x. It's kind of a weird function. Let's move on and find the equation of the asymptote. Now, take note. For some other random function like h of x, say h of x equals 3 to the x plus 5. This plus 5 is the asymptote. The asymptote would be y equals 5. So the number hanging out here, after you've done your exponential expression part, this number on the end is the asymptote. So if we look at this, the number on the end here, it's not there. So it must be plus 0 then. And so y equals 0 is the asymptote. That's where it comes from. Now y equals 0 is the x-axis. So we have a function that's just below the origin here, and then it's asymptotic to the x-axis. So, and it's a reflection of this. So it must be coming along here and then going down through that tiny, just slightly less than 0, and then it must take off down below because this is a reflection. Let's take a look at it. I made a grid, and we can start to put points on it. Where did that point come from? That's that y-intercept. Kind of looks like the origin, but it's just a tiny bit below the origin. So tiny you couldn't even imagine it. Where did this point come from? Now you see, you've got to use a little strategy. If I'm trying to graph this, I'm going to think of x values that I can think about in my head. Now if I plug a 3 in there, x equals 3, 3 minus 3 is 0, and 4 to the 0 is 1, and negative 2 times 1 is negative 2. So the point 3 minus 2 must be on this graph, because if I put in 3 for x, do the math in my head, 3 minus 3 is 0, 4 to the 0 is 1, negative 2 times 1 is negative 2, so it goes to 3, negative 2. There it is. Now this graph must, because it's a reflection of f of x, come up here, through there, and asymptotic. And it does, because that's the software. I plugged it into software. Take a look. We just know this, and we know its shape. It's a reflection of that other one. And so it comes up steeply, 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 and that's practically on the asymptote, and it gets infinitely close to the asymptote. That's what the software says. Moving? Oh, yeah. Label your graph. Moving. Next problem. A cup of hot liquid was left to cool in a room whose temperature was 20 degrees centigrade. The temperature changes with time according to the function T of T equals 80 times a half to the T over 30 plus 20, where T is in degrees C and little t is time in minutes. So playing the role of x in this function, we have little t, time in minutes, and playing the role of y, we have T of T. So that would be the y-axis here, temperature, in degrees C. Let's sketch the function. Well, to sketch the function, we're going to need the asymptote. We've already discussed it's this number over here. So y equals 20 is the asymptote. And we're going to need the y-intercept. To get the y-intercept, you sub in 0 for x, but in this case 0 for t. I literally did it. T of 0, 80 times a half to the exponent 0 over 30 plus 20. Now, I wrote it here, but think for a moment. 0 over 30 is 0. A half to the 0 is 1. 80 times 1 is 80, plus 20 is 100. That's where this comes from. So we know a couple of points on here. We know when we sub in 0, we get 100. This one, where in the world did this come from? 30, 60. Well, let's think. What strategic number could we sub into this fraction to make it a number that we can easily think about? How about the number 30? 30 over 30 is 1. A half to the 1 is a half. 80 times a half is 40. And 40 plus 20 is 60. And so when I sub in 30, I get 60. And so that's where this point comes from. You could get more points. You could sub in 60 and see what you get. Let's do it. 60 over 30 is, well, that's 2. And a half squared is, well, a quarter. And 80 times a quarter is a quarter of 80. That's 20. And 20 plus 20 is 40. So this has to go through, I didn't mention it, but it would have to go through 60, 20. Goes through 60, 20. Okay, so let's see what we can do. We're going to sketch this. We know the asymptote. We know the y-intercept. Let's put it on. There's the y-intercept, 0, 100. There's 30, 60. And we know it's going to go through 60, 20. It's just an interesting observation. 60, 2, 60 over 30 is 2. Half squared is a quarter of 80 is 20. 20 plus 20 is 40. I'm wrong. It's 60, 40. So it'll go through 60 and 40. I didn't put it on this graph, but I did put the asymptote on, and I did use the software, and we can see that, yes, it goes through 60, 40. There it is right there. And of course it goes through all those other points too that I mentioned. Going back, goes through the y-intercept, 30, 60, and it goes through 60, 40. 60, 40, right there. I should have put that one on. And so that's a sketch of the function. That's how you sketch these things. Y-intercept and asymptote. And general appearance as well. Because the 1/2 tells me the shape of this is a decreasing exponential function because the number, base number, is less than the number 1. And just to round this out, how many minutes does it take this liquid to reach a certain temperature, say 45 degrees? So to do this, what we need to do is plug 45 into the result here. T of T, the temperature, is going to be 45 degrees. So it's not going to be 45 of T, it's just 45. Sub it in. Now we have to solve for T. So this is the skill of the unit. This is the major purpose of the unit, I think. Take this 20, drag it across, take it away from 45, you got 25. Don't subtract this 80, divide both sides by 80. When you divide this side by 80, it vanishes, and you divide this side by 80, and you get that number. Try it on a calculator. Now, this is the point. Look. This is our form. It's our form for log over log. So the exponent, whatever it is log of this number over log of that number. Now the exponent is t over 30, not t. And so the calculator will give us this right-hand side as a decimal, multiply that right-hand side by 30, and we have t equals 50.3, and we've answered the question. After how many minutes of cooling does that liquid reach that temperature, 45 degrees? It takes 50.3 minutes.